Hi, welcome back to Algebra 2. Today's lesson is 2.12, System of Linear Equations. But we're going to be expanding that to 3 equations with 3 unknowns from the usual 2 equations with 2 unknowns that you're used to from Algebra 1. All right, so just reminding ourselves what that looked like graphically is if you had 2 equations with 2 unknowns, you basically had 2 linear functions, 2-dimensional, and where they intersected gave us the solution. And of course, we do know that there were situations where if you had something like this red line with another red line that was similar to it, so you had this red line and then maybe you had one that was parallel to it, you'd know that there were no solutions to that. Or there might even be the situation where you'd have this one, and then you'd have another line that was similar to this one that might be like x plus y is equal to 3, which is exactly the same line, and then there are infinite solutions to that systems of equations. So that's what we did in Algebra 1. What we're going to do today in Algebra 2 is we're going to think about this now, and it's very hard to try and talk about what this looks like, but what we're going to do is we're going to expand this to 3 equations with 3 unknowns, which create not linear functions, but linear planes. Like think about pieces of cardboard intertwined together, and where those cardboard pieces meet, there's really only one point, and those are the ones we're really going to be concentrating on this year. But there are a possibility of having infinite solutions, because if they all meet, if they're parallel planes, there'll be no solutions, and if they all meet in one particular line, there are infinite solutions. So if you want a little bit more information about this, that might, and it's kind of babyish, but it's a great video that we're going to show in class. But if by chance you miss it, this is the link to it. I don't think you can click on this. It's not a clickable link from where you are in this video, but you can basically try to type this into your browser and watch it on YouTube. All right, it starts with a little cartoon guy, but like I said, I think that the information that is given during that video is really valuable and it would really be helpful to you. All right, so we're going to continue on to our lesson in our workbook, which talks about the system of equations with 3 equations and 3 unknowns. So exercise 1 starts with 2 equations with 2 unknowns, so I thought maybe I'd make it a little bit easier for you when we would just solve these using any way that we can that we might remember from Algebra 1. So what I would like to do in exercise 1A is that see how I have this y all by itself? What I'm going to do here is I'm going to solve this equation for y. And now I'm going to use substitution because that's one of the valid methods. So we're going to take our equation that's up here, and wherever there's a y, so 3x plus 2y equals negative 9, and where there's a y, we're going to put our negative 2x minus 7. And now we're going to solve this for our x value. So in this case, I'm going to get 3x minus 4x minus 14 is equal to negative 9, which is negative x minus 14 is equal to negative 9. Add 14 to both sides. Negative x is equal to positive 5. So x has to equal negative 5. So that's using the substitution method. Now don't think you're done, because you're not. You have to go back and solve for the y. Because remember, what they want you to find, the system of equations, are all variables that are represented here. So what I'm going to do is go back to my y equals negative 2x minus 7. I'm going to substitute in my negative 5, and I get negative 2 times negative 5 minus 7. So y is equal to positive 3 when I'm all said and done. All right, so there's my x, there's my y, and then we would always go back and check it. But I'm going to avoid that step for now because I'm going to show you, don't tell anybody, I'm going to show you a little way to cheat on your calculator that we're not going to have to check it. All right, so, but like I said, don't tell anybody because I don't want to lose my job because I'm teaching you how to cheat in math. All right, so moving on to B. Now, instead of using substitution here, let's use elimination because this is really going to have applications in our 3 by 3. And what I mean by eliminations is if I look at our variables here, I can either eliminate the x's or I can eliminate the y's. So I think I can be easier to eliminate the y's because then I could just have to do one multiplication here. If I multiply the top and the bottom, I'm sorry, if I want to get rid of the x's, that means I have to multiply this one by -2 and this one by +3. So I get a -6 and a +6, and that's just too much work. So I always try to find the easiest way out. So what if I multiply this one through by -2? So this stays the same, and this one becomes -4x minus 2y is equal to +14. So do you see what happens here now? So in this case now the y's cancel out and I get -x is equal to -5 and x is equal to 5. So notice these are the same problems. So here I have x equals 5, I'm sorry, -5. Here I have next x equals -5. I have x equals -5, and then you're going to follow the same process. You're going to write down one of them, 3x plus 2y is equal to -9. It doesn't matter which one we do. 3 times -5 plus 2y is equal to -9. -15 plus 2y is equal to -9. Add 15 to both sides. And 2y is equal to -6, nope, +6. +6, divide both sides by 2, and y is equal to 3. So you get the same answer, all right? Two different methods, you get to the same place. And that's why we tell you so many times, in math, we have multiple pathways to get to the same answer. So the beautiful thing about these systems of equations is that you might be working in a group of 4 people and not one of you will do it exactly the same way. And that's the kind of individual thinking we want to see. We don't, the first few times you might want to discuss it and all do it the same way. But then when the time really comes to, try these on your own, and we're giving you problems to try, you should really be trying them all on your own. And like I said, I'm going to show you a little trick on how to come up with the answer first. All right, so here we are on exercise 2. So here we have a systems of equations. So now what I just started saying is that there is a way to put this into your calculator and it will come up with the answer for you. Now remember, the answer is only worth 1 point on a good day. All right, so you can only use the answer to really help you guide you towards the right answer. So I'll show you what I'm talking about. So go to your calculator. Now you don't have your calculator with you right now, so obviously you're not going to be able to do what I'm doing. Let's get rid of this stuff. Sorry about that. Should have had that prepped and ready to go. All right, so what we're going to do is we're going to go to our calculator screen, and then we're going to go to menu. You go to menu. Remember we did this once before, and we went to algebra, and we went to numerical solve, but this time we're going to do systems of equations. Now, if we're doing an algebra 1 question like we just did, we'd put 2 in. But in this case, we need a 3 by 3. And you don't actually have to put the z in. The only time you have to touch variables is if you're doing maybe an a, b, and c instead of an x, y, and z. So all you have to do is use your toggle button to, nope, that's not what I want. Delete, I want 3 here. You have to use your mouse to come down to OK. And when you hit OK, the z automatically gets put in for you. And we're just going to put this in just like it shows up on our paper. So 2x plus y plus z is equal to 15. Now, one thing I will tell you is make sure you are putting them in properly, because one mistake is a big problem. Minus 3y minus z is equal to 35. All right, so negative 4x plus 4y minus z is equal to negative 14. All right, so once you put it all in and it looks like this, again, my advice is before you hit enter, just double check. It really just takes a moment to double check your work. And from here, it's looking pretty good. Negative 4x plus, make sure you're also making a difference between the negative and the minus sign. All right, the negative it always shows up small on the calculator, like before the 4 and the 14, and the minus is a little longer. So when I hit enter, bam, there's my answer. X is 7, Y is 3, and Z is negative 2. Now, like I said, it's cheating, but it's really only going to help guide us a little bit. So before I even start, I'm going to come up here. I'm going to put those set notations and write 7, 3, and negative 2. And even when I make mistakes on these, I do this first, so that way it kind of guides my thinking. And I know if I don't get my first variable to work, then I know the next two are never going to work. So when I take a look at this, I look at, am I going to get rid of the x's, the y's, or the z's? And usually one of them will kind of stand out. And if you look, see how the z's have positive z and negative z? So that's a really good choice. So I put little numbers here next to them so you can kind of see equation 1, equation 2, and equation 3. So the first thing I'm going to do is I'm going to take equation 1 and I'm going to add it to equation 2. So I have 2x plus y plus z is equal to 15. Now watch those z's, they look like 2's. 6x minus 3y minus z is equal to 35. And when I add these, and I always like to add them because I like to have opposite signs, and in this case the z's will cancel. All right, so what I'm trying to do here is I'm going to try to take 3 equations and create 2 equations with 2 unknowns, just like we did in Algebra 1. So here we have 8x minus 2y is equal to 50. So why don't we call this one equation 4? But now we have to go back and do it again. Now we used equation 1 and 2, which means we have to use equation 3. So this time I'm going to use equation 3, and because it's a minus z here, I'm going to add it to equation 1. So you can add it to 2 or to 1, but to make it easier, I'm going to add it to 1. So minus 4x, doesn't matter which one you put on top, 4y minus z equals negative 14. And then I'm going to put the number 1 underneath it, plus y plus z is equal to 15. And you can see how the reason I did this one more time is because the z's are going to cancel. You have to have the same variable cancel in both equations, all right? Because it won't work if you go the other way. So this becomes minus 2x plus 5y is equal to 1. And let's call this equation 5. Now you don't have to put the equation numbers in. For now, I just figure it might just be easier for you to see them. Also, if I don't give you enough room to do these, feel free to put them on notebook paper and staple them into your notebook. Okay? Please, because if you're trying to squish these into an allotted space, it gets messy. All right, so let's take our 2 equations now. So let's take our equation 4, which is 8x minus 2y equals 50, and take our negative 2x plus 5y is equal to 1. Now we have to eliminate either the x or the y. And I always try to get away with just doing one multiplication if I can. And in this case, I think I can, because if I see this, see how the x's have different signs? I have a positive 8 and a negative 2. So if I simply multiply this through by 4, I'll get a negative 8. And that's what I want. So 8x minus 2y is equal to 50. Negative 8x plus 20y is equal to 4. And now let's add these together. And we cancel these out. And I'm going to get 18y is equal to 54. Divide both sides by 18. And y is equal to 3. Now, before I do anything else, this is where that little cheating tip comes in. I look up here and I say, wow, my y, remember this is x, this is y, this is z. My y is 3, and I got 3 down here. Once that happens, the rest of it is cake. All right, so what we're going to do now is we have one of our variables. We need definitely to find one of the other variables. So what we're going to do is we're going to go back up to our first equations 4 and 5. We're not going all the way up to the top yet to 1, 2, and 3. All right, because I only have y is equal to 3. So I have to use one of these, and it doesn't matter which one you use. So 8x minus 2y is equal to 50, and 8x minus 2 times 3 is equal to 50. Now I know what the answer is already, and so do you. Minus 6 is equal to 50. Add 6 to both sides. 8x is equal to 56, and x is equal to 7. Well, it's very nice, but I already knew that because that's what I have written up here at the top. So x equals 7. But every time I'm working on this, I'm getting point after point after point. We're so happy. So now the last step is now I have to go all the way back to the top and pick one of those equations up at the top. So let's just choose, well, let's just for easy, let's just pick the first one. 2x plus y plus z is equal to 15. So now I have two of these that I can plug in. 2 times 7 plus 3 plus z is equal to 15. Now beware, notice how when I make my 2's, I loop them. I'm not normally that kind of person. I usually make my 2 like this. But when I'm working with my z's, the 2's and the z's look so alike that I make sure I loop my 2 when I'm dealing with z's. Just a little trick there. So 14 plus 3 plus z is equal to 15. So 17 plus z is equal to 15 minus 17 from both sides, and z is equal to negative 2. Good. I knew that already because we got the answers. All right, now this turned out, it always looks easy when someone else is doing it, but I will tell you when you're doing these, you will be making mistakes, and you make stupid mistakes. You multiply wrong, you do the wrong signs. I know that for a fact because that's what I do. All right, so make sure that when you make a mistake and you're not coming out with a nice number for that very first variable, you go up and find your mistake. Don't ask me to find it. Don't ask somebody else in the classroom to find it. That's your job. Okay? Your job is to go back and find your mistake. And sometimes it requires you just throwing that piece of paper out and starting all over again. All right? So we have two more problems to do, which are a little bit, lengthy. And I don't want this video to go on forever. So I think what I'm going to do is I'm going to let you try exercise 3 on your own, and then I will put the solutions up, and then maybe exercise 4 we'll come back and do it again. All right? So exercise 3 is this one right here. Again, it uses x, y's, and z's. All right? So I'm going to tell you, I'm going to do a little cheating for you and tell you the answers. -5, 8, and -2. So I know you don't have a TI Nspire at home with you, at least most of you don't. All right, but if you do, you should absolutely be practicing this. All right, so knowing those are the answers, see if you can come up with the first variable. But I can help you a little bit looking at this. If you look at the x's, the y's, and the z's, what variable do you want to eliminate first? The answer is you can eliminate any one you want to. The easier one, I think, to eliminate would be the y's, because you have a positive 4y and you have a negative y. So those two, I just have to multiply that bottom one through by 4, and the top one I'd have to multiply through by a -4. So, okay, maybe we should try and do this together. And the last one, I'll put the solution up. All right, so if you like the numbers, if you don't like the numbers, don't worry about it. Here's 1, here's 2, here's 3. So the first thing I'm going to do is I'm going to write down 1 and 2. So I have 4x plus y minus 3z is equal to -6, and -2x plus 4y plus 2z is equal to 38. Remember, do it on line paper if you don't have enough space, because trying to do this quickly and compactly only ends in disaster. All right, so because I need a negative 4 here, I'm going to multiply this through by a negative 4, and I get negative 16x minus 4y plus 12z is equal to 24. And the other one, I'm not changing. So negative 2x plus 4y plus 2z is equal to 38. So I'm going to get negative 18x. These are going to cancel. That's why we did it. Plus 14z is equal to 62. So we're going to call this one equation 4. So the next one's a little bit easier because this time I'm going to use 1 and 3. So 1 says 4x plus y minus 3z. Probably should have done this one first. I usually like to do things easier ones first. 2x minus y minus 7z is equal to negative 19. These cancel. I get 9x minus 10z is equal to negative 25. So we'll call this one equation 5. All right, so let's take these two now, 4 and 5. So we have negative 18x plus 14z is equal to 62. We have 9x minus 10z is equal to negative 25. I think it's easiest to get rid of the x's and multiply this through by 2. This stays the same. This changes to positive 18x minus 20z is equal to negative 50. These cancel. I get negative 6z is equal to negative positive 12. Divide both sides by negative 6. And z is equal to negative 2. And that's what it is. Yay, I was going to have to look up, but nope, I have it right here. Z is equal to negative 2, and that's what we got right here. So as soon as you get that part, the rest of it, take a deep breath, because you know the hard stuff is over. That's the hardest part, getting to that first variable. All right, so now I'm just going to slide up a little bit. Oh, I don't even have too much further to slide up. See, this is what I'm talking about. I need more space than what I gave you. So let's take this blue one here. So now we have to go to either 4 or 5. And since I have 5 sitting right here, I'm going to use 5. So I'm going to say 9x minus 10z, which is negative 2, equals negative 25. So you get 9x plus 20 is equal to negative 25 minus 20 from both sides. And you get 9x is equal to minus 45, and x is equal to negative 5. Is that right? Yes. X is equal to negative 5. All right. And now the last part would be just to solve for z. So I have to go all the way to the top. Now remember, it's kind of like you go halfway to 4 or 5. Now you go all the way up to the top and use one of the top ones. So let's use the first one, which is 4x plus y minus 3z is equal to negative 6. And 4 times negative 5 plus y minus 3 times negative 2 equals negative 6. So negative 20 plus y plus 6 equals negative 6. So y minus 14 is equal to negative 6. Add 14 to both sides, and y is equal to which we already knew. So here we have our z is -2. And again, I'm kind of sorry I was all over the place here. Trying to stay a little bit more organized might be a good idea. But what you can always do here is kind of just do this, like here's your first one, and then here's your second one. All right, as long as you can make it understand your thinking. I promise you, if I ever give you a test or you're ever given this on a Regents exam, you'll be given an entire sheet of paper. All right, so it'll be very easy to organize your work. And like I said, if this is confusing to you, just do it on line paper. That's it, because these half sheets just aren't doing it for me either. So I'm going to now let you have a chance to try exercise 4 on your own, and then I'm going to put the solutions on for you. All right, so that should be the last thing. I'm sorry this is a little bit of a long video, but unfortunately it is a long process. All right, but I promise you, if you invest the time in it, when you come in and you start doing these on your own, you're going to be golden. You're going to know exactly what to do. All right, so now with this one, if you put this into your calculator, you're going to change it instead of X, Y, and Z, you're going to change it to A, B, and C. And right away, I'm going to give you the answers. I'm going to tell you A is -1, B is 3, and C is 7. So there are the answers. Now go for it. All right, see if you can come up with the right answers, and I will put my solution on here for you to check. But again, my solution might not be the same as yours. All right, looking at A, B, and C, which one would you get rid of first? I don't know. I think I'd probably go for the A's, but like I said, it doesn't matter. So give it a try. I'll put up my solution. When you're done, you can check it, and we will be done. Okay, well, even as I was doing this one, I almost made a mistake because I got B was +3. And I wrote down -3 by accident. So I'm sorry about that if you guys were getting confused. It is a -3. So when I got down here and I got +3, I said, oh, I'm right. But then when I got to my A wasn't right. So my apologies for that. You probably were goofing around too much and thinking to yourself, holy cow, she's nuts that she's getting the answer for this. But and as I started it, I realized C was probably the easier one to get rid of instead of the A, but it doesn't matter. You should come up with the same answer. All right, so don't worry. We're going to have lots of time to work on this. We won't rush through it tomorrow or the next time we meet. All right, so until then, always make good choices. Have a good day.